Hi everyone, Mr. Ince here. This video is going to go over our notes for section 4.5, triangle congruence with ASA, AAS, and HL. So now remember where we are right now. We've been discussing this idea of congruence and what it means for two shapes to be congruent. We've also already discussed certain postulates or shortcuts such as SSS, which refer to side, 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 as well as SAS, which was two sides being congruent, as well as the angle that's included between those sides. Now you might be able to already predict where we're headed based on these names. These are going to be the final three shortcuts that we use when it comes to proving triangles congruent. So let's go ahead and get rolling. The first one that we're dealing with is ASA, angle, side, angle. Now remember, the order of this is important. And the fact that that S is sandwiched between both of those A's on the outsides is important. This reads that if two angles and the included, keyword, included side of one triangle is congruent to two angles and the included side of another, then those triangles have to be congruent. So you can take a look at our picture. We have two angles as well as the side that is included or sandwiched between those angles. And that's congruent to two angles as well as the included side of the other triangle. So then you can just go ahead and stop. I shouldn't say stop, but you can conclude that those triangles are congruent. Next one, AAS. Okay, so that is two angles and one side, and I should say a non-included side of one triangle is congruent to two angles and a non-included side of the other. You can also stop and conclude that those triangles are congruent. Now, let's talk about this non-included side situation. A non-included side, for instance in this triangle, we have two angles, and then as you continue around, angle, angle, and then this side over here. This side is not included between those two angles. For this picture, side FG would be included between those, whereas this one, as you can see, is not included. Our final one involves a couple letters that we haven't used yet with this topic, and that's HL. HL is referring to hypotenuse, leg, and as you might predict, this only deals with right triangles. So this would read that if the hypotenuse and one leg of a right triangle is congruent to the hypotenuse and one leg of another right triangle, then those right triangles must be congruent. So now remember how to find these things. You have your right angle here, and the hypotenuse will always be opposite of that 90-degree angle. So you can see that in this picture. We have the hypotenuse of one is congruent to the hypotenuse of another, as well as this piece right here, which would be the leg. So we have HL of one congruent to HL of another. All right, now let's try some of these out. Let's try some samples, or examples, I should say. This reads as decide whether enough information is given. So remember, decide basically is saying, hey, yes or no. Can you state that there's enough info to prove that those triangles are congruent? If there is, state the congruence postulate you would use and explain your reasoning. I really want to emphasize that explain your reasoning concept. Remember, you guys know that you're developing kind of an arsenal of tools and statements and reasons in order to justify your thinking when it comes to congruence. So let's give this a shot. We're going to bounce around a little bit in a certain order. I vote that we start with, we'll go A, B, D, and then we're going to slide over and work on C and G at the end. And we'll go ahead and just X out E and F for now, but those would always be good practice problems for you later on. All right, example A. Let's do this. I'm going to try to zoom in a little bit, not so sure how to do it. Hey-o! With this camera, so please be patient. There we go. All right, a little bit closer. Let's do this thing. So for example A, I'm looking at this and I'm telling myself right now that this day, this lesson, is based around three different shortcuts. ASA, AAS, as well as HL. Okay. So we're going to attempt these questions with those three shortcuts or postulates in mind. I'm looking at this picture. I immediately see that I have an angle and a side congruent to an angle and a side. Now I also notice that right here surrounding point E, I could identify that vertical angles are congruent. We're a little bit short on space there, so I'm just going to do some abbreviating. So vertical angles are congruent. Now, that puts us in a situation where we could say we have an angle, a side, and an angle. And that side right there is sandwiched or included between those two angles, as well as the same with this other triangle, angle, side, angle. So we could finally just say yes, as in yes, those are congruent by ASA. Not too bad. Moving on. Let's take a look at example B. We currently have an angle and an angle of one triangle congruent to an angle and an angle of another. I notice this side right here, side QR, is the same size in both triangles, and so I could quickly identify that since I added some markings to the picture. I'm going to justify my reasoning by saying that it's the reflexive property is what allows me to make that statement. And I now have an angle, side, angle in that order congruent to an angle, side, angle. So this one as well would be yes by ASA. All right, 2 for 2. Moving on, let's jump over to D. We're kind of going in a certain order. This one has a little bit more difficulty to it. So let's strap in. Taking a look, we don't have a ton here. We have one angle in one triangle and one angle in another. However, you do have a certain piece of notation that wasn't in the previous ones, and that's that these two lines or segments are parallel to each other. That makes me start to think about all those other parallel discussions that we've had previously in the year. Before we dive into that, let's note that AC is right there and it's shared by both triangles and it's congruent to itself. So I'm going to go ahead and refer to the reflexive property. Okay, so now we have an angle and a side congruent to an angle and a side. We're getting close. The reason I brought up the parallel lines, you'll notice that we have two parallel lines that have essentially been cut by this transversal. And what that does is that allows me to say that this angle right here, angle BCA, is congruent to this angle right here, angle GAC. And the reason behind that is that when you have a little bit of abbreviations here, parallel lines cut by a transversal, comma, alternate interior angles are congruent. Woo! That's a mouthful, but we did it. So now when we take a look, we have three different markings in there. We have an angle, angle, and a side that is not included between those angles, congruent to an angle, angle, and once again a side that is not included. So that means that we could finally say yes, these triangles must be congruent, and that's by AAS. Let's slide over to the right and try to tackle the difference or differences between examples. Did I just say betweens? I think I did. We're already 9 minutes into this video, so we're going to keep on rolling. But a word of advice, don't use the word betweens. Just doesn't sound good. Okay, back to business. Let's take a peek at example C. The first thing I notice is that I'm dealing with a right triangle. And that is making me wonder, could this be hypotenuse leg? Maybe, since that's the one that deals with right triangles specifically. But remember, you can't purely trust the size of the picture. You have to trust the information that you know in the picture. So right now we only know that this currently has an angle. And I suppose we could mention that this side is congruent by the reflexive property. But that's it. We don't have anything else. We're not allowed to just make up information about these outside sides or these ones here. And so what that means is right now we just can't go any further, and we'd have to say no. There's not enough information to prove that these are congruent. But let's take a look at the example below and how this one creates something different. I notice right here that I do have a right triangle on the right, and if this angle is 90, then this one has to be 90, and that's due to a linear pair. You've got two angles that create a straight line, which means it's 180, and if you use 90, this has to be 90 as well. I notice that this one does have these markings already provided, so that was a given for us. And then we could go ahead and add the 2 dashes right there for side RT, and that's once again due to the reflexive property. And now that I take a look at this, these sides right here, that's the hypotenuse of each right triangle, and then side RT would be considered a leg of each of those right triangles. So we have the hypotenuse leg of one triangle congruent to the hypotenuse leg of another triangle. So we could close out by saying yes, they are congruent by HL. Okay, we're almost home. Let's go ahead and flip over and try to tackle another style of question. Don't mind me here while I flip my page. And we're back. Remember, at any time during this video, you can always just pause and rewind and just try to go at your own speed. Okay, there's no need to rush through this stuff. All right, this second style of question is a little bit different. It's presented to you and says, state the third congruence that would need to be given in order to prove that triangle ABC is congruent to triangle DEF using the indicated postulate or theorem. So example A here, it's kind of like saying, hey, listen, I'm giving you some information here, and I need you to use the angle side theorem, but I'm going to allow you to make one more statement of congruence. And then with that one statement, you could then finally use AAS. So I treat this like a checklist. I tell myself at first that I have a side and a side, so that takes care of that. I have an angle with an angle, so that takes care of that. Now, that means that my congruence statement needs to be about an angle, and it needs to be an angle that does not have the side included. You'll notice that the side is just kind of out there, hanging out by itself, and so this angle needs to not sandwich that side right there. So that means instead of choosing angle B being congruent to angle E, that would be ASA. I'm going to go ahead and select angle C would need to be congruent to angle F, angle C congruent to angle F, and after that statement we would be able to use AAS. Let's take on, how about, what the heck, let's keep it rolling. We're going to do B, C, and then we're going to close it out with the final one of A. So 3 more. We're almost there. Thanks for sticking with me. If I had a good joke, I would try to say it here, but I don't, so let's just keep on talking triangles. All right, example B. We're required to use side angle side. Oh, that's going back to the previous topic. It's all right, let's do this. So we have one side congruent to one side, and then I take a look at point B, and I'm telling myself I've got some vertical angles, so I'm allowed to state that those angles are in fact congruent. And if I'm supposed to use side angle side, I already have a side with a side, so check. I have an angle with an angle, check. That means that my statement needs to be about a pair of sides, and it needs to be the sides that makes the angle that we have included or sandwiched between them. So that means that I'm going to select side GT being congruent to side UT, and with that statement we could finally use SAS. Example C. This one's a little bit unique in that it uses HL. Once again, that's hypotenuse, leg. So you have to be careful with your right triangles. We're already shown right here that this is a right triangle on the right side, which keep in mind that does mean so is this. That's based on the fact that this is 180 degrees total, and if 90 have been used here, this must be 90 as well. Based on the reflexive property, just going to do a little bit of abbreviation here, we could say that WV is congruent to itself, and that would be the leg of these right triangles. Let's go ahead and pretend that that's an L. Those are my intentions. There we go. Now, if we've taken care of the L, the leg, that means that we need to make a statement in regards to the the plural of hypotenuse. Hypotenuses? Perhaps hypotenae? I'm not sure. I'll have to look into that. But we need to make a statement about the hypotenuse in each of the triangles. And remember, go to your right angle and then go to the opposite side, and that's where you'll find the hypotenuse hanging out. So that means that our statement will be about WX being congruent to WI. Okay, not bad. One more. The above three examples gave us visuals to work off of. And what's different about example A here is that there's nothing. We don't have any sort of visual to go with. So it gives us the same set of directions, and then it gives me a couple of givens. And then it is asking, use angle, side, angle. This is a lot to try to take on without a picture. I would strongly recommend creating a quick picture that deals with these triangles. You'll notice the congruence statement that we were given, and that means that I do need to stick in that order. So next to problem A here, I'm going to go ahead and just draw two basic triangles, and I'm going to make sure that I follow this exact order. So on my top triangle, I will do D, E, F, going around the shape in a clockwise direction. And I'm going to follow that up with the same order of M, N, O, going around in a clockwise direction as well. Now when I'm presented with these givens, I can go ahead and make my tick marks and arcs in the picture. So I'm told that side EF is congruent to side NO. So side EF, you're right here, is congruent to side NO. And I've now made those markings. And I've also been told that angle N is congruent to angle E. Angle N is congruent to angle E. So now that our givens are in there, we're required to use angle, side, angle, and we're allowed to make one more congruent statement that would make angle, side, angle work. So using my checklist, I already have an angle, check. I then have a side, check. That means that my one statement that I need to make is about an angle, and it needs to specifically be the angle that makes the sandwich, I must be hungry, the side sandwiched between those angles. So I'm going to go ahead and select angle F being congruent to angle O. Angle F congruent to angle O. And then this would complete the angle, side angle, congruent to an angle, side angle. Whew! We did it! Well, thanks for watching. Remember, I'm going to be checking to see that you got this far in the video, as far as completion. And then go ahead and transition into today's assignment. And that assignment is on your calendar, both online and on the paper calendar. And it's also written up on the board. I hope you guys have a terrific Monday while I'm sitting here in the courthouse for jury duty. And I look forward to seeing you guys in class on Tuesday.